Hello guys, in this part we have denormalization. As you know, we use a database to create, read, update and delete operations. These four operations we call them CRUD. So in that case, we are using normalization guidelines described in previous videos to gain a better performance. Sometimes it is not always the case that normalization will produce a better performance database. So in that case, we should regard normalization and normal forms as guidelines rather than rules when designing a database schema. In this lesson, we need to explain the denormalization means, describe the benefit of denormalization, use denormalization techniques, and finally describe some consideration for denormalization. Let us start with it. Now, as a reminder, we have two types of relational database schemas. We have OLTP, the transaction processing one, the normal one, which we had used it to practice normalization. And the second one is the data warehouse, which is Star and Snowflake. These are the two types. So with OLTP, normalization is going to work fine. With the Star, I prefer to use the denormalization. And the reason is because of the query. The query is going to run faster with a warehouse when you have denormalization. And in a warehouse, as we had explained before, all the branch offices who they are of type OLTP are going to send their data maybe on monthly base to the warehouse. We have millions, if not even more, of a transaction and records. And the query to run between all these splitted tables, find relationship, and then gather information from each table to present it in a report, it might take a longer time. So in that case, for the warehouse, maybe it's better to use the denormalization technique. What we can do for a better practice of denormalization, we need to normalize first the database which we have. Then we are going to see what to be selected for denormalization. And of course, we have an example to make things clear. We can achieve denormalization in various ways, including we can reintroduce tables that were decomposed during the normalization process, or duplicating attributes across multiple tables, or duplicating entire tables or part of tables, or finally storing derived data that we can calculate from existing data. Now, if I look back to the example which we had in the previous video. Now, what is the optimal approach for this design? In this design, from the beginning, I already have this single table, which I decide now to follow the normal forms and normalize it. From the beginning, maybe it's better in case I have a data warehouse and I'm aware that we might have a problem with this kind of design, then I need to make two designs. The first design, I will make my OLTP design, which is this one for the relational database, the normal one. And here I'll define, of course, the relationship keys, etc. And then also I make another design, and in that design, it can be used for data warehouse. So maybe I will select some of these fields or tables, and those tables for the data warehouse, I might add even more columns to it. Two tables, mix them in one big table. So the query is going to run easier on such design when we have a data warehouse and so on. So all the time from the beginning, if you have a good design, then later you are going to save time and efforts. And of course, by this, you will save cost. Otherwise, if you want to do something later, then expect additional delays and cost. We need to talk now about the benefit of denormalization. It's going to improve query performance. It's going to support reporting applications for sure, because report applications depends on query performance, improve concurrency of data and ease of use. Discuss a bit about each one of these. With the query performance, as you know, queries can often require joins that involve many tables, and the process can be relatively slow when compared to retrieving rows from just a single table. So this is why the query performance gets better. Reporting application, because depends on the query performance, then you can get a better reports in a shorter time. And then the benefit of concurrency is when users attempt to access data concurrently, the RDBMS must ensure that inconsistencies don't occur. For example, if one user reads the data value from a table and a second user at the same time updates the same data value, the first user data is now out of date, and the subsequent decision that they make using the data will be based on inaccurate information. RDBMS use mechanisms such as locking to handle these kinds of situations. So locks prevent application from making changes to data if that data is being used by other applications. Now, in case many users need access to the same tables at the same time, locking can impede performance because applications have to wait until resources are released before making changes. By introducing redundant data now, you can potentially reduce the impact of locks and improve performance. And finally, with the ease of use, a user who query a database need to understand the database schema, all these transitive and transaction database, so he can locate the required attributes and understand how these attributes relate to attributes in other tables. When you denormalize a database, in that case you might have only a single database and a full row will contain the information relating to, as an example, an employee, and it will be easier to follow all the information relating to that employee. Instead of study all the relationship between different tables to retrieve back all the information relates to him. Again, take a look to this table. Now, if I present all these tables to you for the first time and you are not the one who normalized it, you might need some time to figure out the relationship between the tables and then build a query which is going to retrieve back a piece of information from each table to get finally a full record belong to this employee. While if we have denormalization and we have a single table, in that case you just need to look to this row, make a query to select all the attributes of this row, and that's it. You gain the information relating to your user or to employee. Next, we have to discuss techniques which we can use for denormalization of database. We can add redundant columns using report table, duplicate tables, split tables, reintroducing repeating data groups, or using calculated and derived columns. With redundant columns, let us again have an example. In this example here, I split doctor information into two tables because I assume some doctors, they don't have specialist region number. So maybe now to avoid the problem that a query to retrieve back the information of the doctor need now to run a joint query, because here some doctors, they have specialist region number and I want it to be appear in the report, and some others they don't have. All what can I do? I can now replicate this column into the main table. Either it has information or not, and later I can design a query to target only this table because this table now contains the information relating to the doctor, including the specialist region number. The side effect of it, if the doctor has no such number, then the field here is going to be blank. It's going to waste space definitely, but I need to estimate. If it is a data warehouse, maybe that solution is accepted, because what's important in that case is the performance of the query. Now, the other technique is by using report tables. And the reason why do I need to create a report tables, it is to handle queries for a specific report or set of reports. Because reports generate queries that require a great deal of processing power and take a long time to run because they often contain multiple joins and complex calculations. So for the report table, which sometimes we call it also pre-joined table, the table which contains all the attributes and calculations required to serve reporting queries, so that the joins and calculation do have to be performed when the report is generated. Because a report is typically a snapshot in time, it is not usually necessary to keep report tables synchronized with other tables. You would repopulate the report table periodically. So that's why we need to have it, because the report table can help me now to save some time when I want to build some queries. Then we have duplicate tables. This technique also we call it mirror table. Imagine a scenario. I have a table and two applications need to access to this table. One application to update the table with data and the other one just to read information and perform queries for reports. Now, if I duplicate the table, by this, one application will be assigned to the first table to update it, and the second one will be assigned to the second table just to read information, and by this we are going to improve the performance. Split table is an instance of duplicate tables. The idea is with split table, again, I have a single table and I have two applications need to access to it. One to update some information, the other one just to retrieve back information. So maybe I can split this table into two tables. The table where the fields need to be updated, then the first application will assign to it so it can update the fields, while the other table where the information is constant, the second application can be assigned to it just to retrieve data and display it in case of report. Again, when we have two tables, one application assigned to each table, we improve the performance comparing to a single table and two applications want to access to it at the same time. The other technique is to use reintroducing repeating data groups. Let us check again our example. In our example, if I try to avoid normalization and I use a single table, here again we have a problem, which is in case a user has more than one laptop, then I need to create two records for him. and that might increase the performance later with any queries. So instead, what can I do? I can add another column for a laptop. So by this, he can hold now 2 laptops, and maybe another column for mobile also. So by this, the company can give him again another mobile. So it is a maximum of 2 laptops and 2 mobiles. Maybe some users might get only 1 laptop. So in that case, the other field in the second column is going to be empty. But by this, I mix the technology or the benefit of the 2 words. I still have denormalized database, and at the same time, I'm not going to repeat the records for the same user. I just add additional column that it might hold an additional data, or it might left blank. It depends. This is what we call it now, a repeating data group. And that one is not going to affect the performance. It's just going to affect that I might have some lost space because I have blank data. The last technique which we can follow is using calculated and derived columns. The idea is simple. Assume that I have 2 columns for first name and last name for employees. I can join both of them in a single column. So instead of 2 columns, I need to forget about them. And in a single column, I'm going to mention the first name and last name. By this, the processing time is going to be reduced because the query, instead of looking into 2 columns, is going to look only to a single column. And these were the main methods which we can use for denormalizing. Finally, few things to take in consideration for denormalization. Denormalized database can be larger, definitely, because we have repeated maybe data table, etc. It can increase the number of null values, because as we had explained, in some columns you might have no value at all. Update must be handled correctly. The likelihood of data anomalies is much greater in denormalized database. Powerful hardware can negate the benefit of denormalization. In-memory technologies improve performance for normalized database, and final testing is an essential part of the denormalization process. Before finish this video, unless we have a data warehouse, currently we don't need to use denormalization, and it is out of the scope of this course. Thanks for watching.